You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Since its inception, Amazon Web Services, AWS, has been the best place for customers to build and run open source software in the cloud. AWS is proud to support open source projects, foundations, and partners.
Hello, and welcome to the latest edition of the New Stack podcast. This week, we're kicking off a three-part series on Apache Flink, and which is a framework for real-time data analysis and analytics. And Amazon Web Services has kicked off a managed service for Apache Flink, and so for this three-part series, for this first part, we'll delve into the what Apache Flink is itself and why you should care. And in follow-up podcasts, we have one just dedicated to discussing AWS's managed Flink service and what the benefits are for that. And for the final part, we'll talk with an actual customer who has been using Apache Flink. So, exciting series. To learn more about Apache Flink, we have a couple of AWS executives. We have Danny Cranmer, who is a principal engineer at AWS, as well as a Flink PMC member. And we also have Hong Teoh, who is a software development engineer and at AWS, as well as a Flink committer. So we're seeing that AWS is putting a lot of skin in the game when it comes to Flink. So let's dive in it. Gentlemen, welcome, and thank you for talking with us.
Hello. Yeah,
Hello.
nice to be here.
Excellent. All right, terrific. So, so first of all, let's assume people don't know what Apache Flink is. What is Apache Flink?
Okay, I can take that one. So Apache Flink is, at a high level, it's a framework where we can define data analytics jobs. Flink supports unbounded and bounded data streams, so that would be streaming and batch jobs, and it has a variety of different APIs which you can use to create your jobs, including Java, Python, SQL, and other languages and APIs. As well as the framework, Flink also provides an engine that you can use to run the job. Jobs run in a distributed manner with fault tolerance built in, and they scale horizontally.
Excellent. So why would I use it? What are some of the common use cases?
Yeah, so like people use Flink for a lot of things, but based on like what Danny was saying, like streaming, extract, transform, load, ETL is pretty common use case. So you would kind of, the moment your data is generated, you want to extract it, transform it, and load it into some of the like output immediately, right? So latency is very important then. So you want very fast and instant transform, right? So Flink is very good for that because it's a streaming. It's able to handle unbounded data sources. So the moment your data is generated, it will process it and output it. Another thing is real-time analytics as well. So let's say you wanted to take in your data in real time. You want to kind of analyze what's happened, generate some insights. Maybe it's business data or sports data, right? And you want to display that on a dashboard. Flink is very good at that because it can analyze things immediately on the fly, right? So anything that's streaming like related. Another thing that's a common use case is something more complex, like a event-driven application. So let's say you want to trigger some event the moment trigger some action when an event is generated. Like Flink can do that. So it consumes the event and performs actions immediately. So anything in the streaming use cases, it's very useful for.
All right, fantastic. We've been covering at the New Stack. We've been covering stream processing a lot in the past year, as opposed to, I guess, batch processing, where it's just you have a big job and you send it on its way and you get it back. Could you guys help us? What is stream processing?
So the easiest way to talk about stream processing, as you just did, is in context of batch, or comparing it to batch, because most people already understand batch because it's a little more intuitive to understand. So for a batch job, typically you would run a job periodically. That could be once per hour, per day, per week. It doesn't matter. But when this job runs, it has time-bounded data. So you already have the full set of data. Therefore, it's easier to process because you can load it all into memory and then you can process it all in one go and generate an output for that block of data. So streaming data is different, or unbounded data, because the source of data is constantly, or it never ends. You're constantly receiving new data. So
Like
you
new
can't load.
tweets. If you're following Twitter or X, or there's always going to be
Exactly.
new data. Okay, yeah.
Exactly. So you can't load everything into memory and process it all in one go. You have to process it incrementally, and you have to output the result incrementally, and it never ends. So that's the main differences between stream and batch processing.
Excellent. You mentioned Flink does both. You can actually do both.
Yeah, so on Flink, one of the selling points of Flink is that there's a unified batch and streaming API. So you can write in SQL, and you will be able to run using the same APIs on a batch and a streaming data. So an example where this would be pretty useful is, let's say you want to read from a backlog, right? You want to read from a big batch, and then you want to transition to some form of streaming data. Flink allows you to do that because you can use the same APIs to define your job. So you could kind of seamlessly transition between.
Oh, nice. Why should an organization use Flink? What would cause them to say we need Flink?
Some of the benefits of Flink, I'll talk through them. So exactly once processing. So what we mean by that is the ability to avoid duplicates. So Flink is a distributed processing environment, and it's very important to only process each record once for some use cases. For example, anything to do with finance, you need to make sure that you absolutely process everything exactly once, no more, no less. So Flink supports that natively. And it also has it also gives you fault tolerance via checkpointing mechanism, which will essentially periodically checkpoint the state of your job, so that if anything happens to fail, you can then restore from the latest checkpoint, and then continue processing. Or if there was, say, a bug in your code and you need to reprocess a time span of data, you can actually go back in time, reset your job from a point in the past, and resume from there onwards.
No, yeah, I just wanted to add to that because I thought I think Danny summarized it very well. It's checkpoints, and to be able to replay from time. I think that's incredibly powerful. And what makes Flink really powerful here is that you can do it on a distributed cluster, right? Because if you want to keep memory in state and you want to replay in time, generally if you just have one instance, it's not too hard to do, right? What's hard to do is you want to run it over, let's say 1,000 machines, and you want all of the machines to be coordinated in the state in which they save. And that's why the checkpointing mechanism that Flink has, that comes out of the box, right? It's able to it uses this Shandy-Lampert algorithm. But the idea is that it's able to take a snapshot of the state across a distributed cluster without stopping the processing. So that's why the idea is that you can kind of it comes out of the box like state management. So that's why it's very useful. And I think another benefit that comes about from this is performance as well, because you can have very, very low latency when you have a streaming data input, right? So let's say you compare to batch where you have to wait maybe 15 minutes, 5 minutes, whenever your batch data completes. For streaming data, you can just, the moment it's generated, you can analyze it immediately, right? So another thing Flink does well is because it does stream processing, it can have very, very low latency. Another thing that actually Flink does out of the box is it does optimization for your job graph as well. So let's say you design some form of data analysis, you want to perform some form of joins, you want to perform some form of maps and some form of reduce. Flink will decide how to distribute or you can tell Flink how to distribute the records across the cluster. So let's say you want to spread it evenly, to say I want all worker nodes to get in, spread it evenly across all worker nodes, or I want to kind of group them by a certain key, right? So what Flink will try and do is that it will, because it's running on a distributed cluster, sometimes you can incur the overhead of transferring the data from one instance to another, right? You want to minimize that as much as possible. You want to run it as much as possible on the same instance, complete all the processing, the entire pipeline, right? So let's say you want to do a map and then a reduce and then maybe a open. So you want to do all of that on the same instance to minimize the overhead of the network transfer. So what Flink will do is we'll try and optimize it for you. So when you define your job graph, you say I want to run this map, this reduce with this key or something like that. Flink will then convert that job graph into an execution graph, how it runs on the cluster, and then it will decide how it can group these operators together so that you will get the more optimized version to run with the least overhead. So Flink does that out of the box. So that's like guidance is one of the key points of Flink, and it tries to optimize that from the get-go without you kind of tuning much.
All right, you guys had mentioned that this is it could be a distributed system. Does this do I require Yarn or Java or what are the deployment options?
So Flink isn't very opinionated here. Actually, there are many options you can choose from. More recently, Kubernetes is one of the most popular deployment options, and actually, there's a lot of work in the community building a new Kubernetes operator, where you define how you want your cluster to, or which resources you want, and then it will spin up all of the components and deploy your job for you, all within the Kubernetes operator. There are other options such as Yarn. There's an old deprecated option on Mesos, and then of course this is just a Java cluster, so you can spin up the JVM and run it like yourself if you want to coordinate all of the cluster yourself, and usefully, you can also spin it up in like in your IDE in debug mode in a mini cluster fashion for rapid development of Flink jobs, which is very powerful.
Nice. Now, so when I think of data processing engines, I think of Spark. How is Flink? Where would I use Flink and where would I use Spark?
Yeah, I guess we can quickly cover them. Like most of Spark is kind of well known. Is a little bit older than Flink, right? So one thing that Flink does better is that it's a streaming engine in its core. So Spark is a batch engine in its core, and Spark supports streaming, but it does it by doing mini batches. So it does really small batches. Flink doesn't do that, right? So Flink just does events streaming from its core. So it's easier, like taking a checkpoint makes sense in Flink's world because you can propagate like checkpoint barriers. This doesn't make sense as much when you're doing a mini batch. I think other than that, I think Flink is generally considered to be slightly faster. So I think like Flink does support sub-second latencies, where sometimes Spark only supports seconds. And a couple of things. So Flink optimizes your job graph out of the box. I think in Spark, it gives you a lot of control, but you kind of have to look, because like you kind of have look how you distribute the job across different nodes, and you have to optimize it yourself manually. I think another thing to mention is Flink has a lot of integrations as well. So I think Flink like reads and writes from a lot of different data sources. So Kafka, Kinesis, S3, OpenSearch, right? And integrates with a lot of different schemas as well. Schema registry, glue schema registry. So I think it's kind of, we want to build the ecosystem, to integrate and read and write from lots of different places. So everyone will use Flink.
All right, fantastic. So, at a very high level, how does Flink work? It sounds like you guys got an orchestrator node and a bunch of worker nodes, or explain that to me.
Yep. So, as you mentioned, at a high level, we have an orchestration node known as a job manager, and then we have a series of worker nodes called task managers. So, for a Flink cluster, we'll have one job manager, and this is where a user will submit their Flink job. The job manager will run the job construction method to build the job graph, and then it will deconstruct it into a series of tasks, and these tasks will then be distributed across the available task managers depending on Flink uses slots. So you have your job requires a certain number of slots. You have a certain number of slots available across your task managers, and then the job manager will distribute these across the task managers. And the task managers can scale out horizontally, sort of in and out, to suit your job or to run multiple jobs. So as well as that, Flink has various options for sort of high availability mode. So job manager, you said, as I just mentioned, there's a single job manager, so you may think single point of failure. So we have different high availability modes where the state of the current jobs can be persisted in a highly available manner to Zookeeper or S3 or Kubernetes, for example. And then while the job's running, we've mentioned state and checkpoints. We have various state backends available to use with Flink. Common options are RocksDB, which will store state to spill to disk or hold it in memory. It's a hybrid model. And there are other options such as HashMap state backend.
All right, fantastic. Now, Flink is an Apache project. It's actually open source. The software itself is open source. What does it mean for Flink to be an Apache project?
Okay, so the Apache Software Foundation, you may have heard of an Apache project before. The Apache project essentially governs the way we contribute to the project, the way the project is run. The governance model defines a set of rules on how and who can contribute, and this is typically it's based on consensus, getting consensus from the peers. We have various types of people that contribute. So we have PMC, which is the project management committee, which will define the sort of direction, strategic direction of a project. We then have committers who actually have write access to the project, and PMCs also have write access. And these are the people who will actually be merging in the code and developing the features. And then we also have contributors who are people that will be contributing to Flink, but they don't actually have write access. So they'll be able to open pull requests, contribute code, but not actually merge it. It would be up to the committers to do that. So the Apache Software Foundation basically sets the rules and guidelines for this project to function like this, bearing in mind that the committee, the committers, the contributors are like anyone can do that. Like, it doesn't matter what company you're from, anyone can become a contributor. One common misconception is licensing. So an open source project is governed also by its licensing, and the Apache Software Foundation projects are governed by the Apache license, which is generally a permissive license. It allows you to like fork the code, make changes, etc. And for Flink in particular, the Flink contribution model is fairly straightforward. Like, as a contributor, I can identify something I want to change. I will discuss this change with the community to get consensus and get buy-in that this change is reasonable, and get agreement for a committer to merge it. Once that's in place, you can open a pull request, get your code reviewed, merge, and there you go. It's in the next version.
All right, fantastic. Well, we've been covering AWS's work in open source for a while. Our listeners know that AWS puts a lot of effort into open source projects. Can you talk about, and you guys are both part of the Flink project itself. Can you talk about AWS's involvement in this community?
Yeah, sure. So I think partly is Flink is very big. There are lots of different areas where we can contribute. I guess part of it is being contributors, so you can see different areas or different areas of contribution that you can start creating pull requests for. So generally, that's how we get started. So Danny is a PMC, right? So he contributed to quite a lot of different repositories. So like the Kinesis connector, for example, like implementing a new feature, a new support. Right, we've worked on other AWS connectors as well. So we've recently implemented one. Well, let's say recently, we've implemented one for DynamoDB, and I think in that case, we were actually working with another company, right? So we're working with people from Klarna, right? So we can see like the cross company collaboration here on open source. And another thing is we drove one of the major changes we drove previously was the async sync framework. So Flink, you kind of write to external data sources, right? And you want to do that asynchronously. So we kind of set up a level of abstraction to allow people to more easily write asynchronous syncs, to write to a data sync more asynchronously. Of course, there are other things. We contribute to any Flink releases or any connector releases. And also, we've been involved in Flink Forward for a while. But I think generally, it's just being involved in the community, seeing what people need, seeing what users of Flink want to develop, and kind of building those things, whether they're connectors or some form of core runtime changes, like the async sync. Mainly just seeing what people need and contributing there.
All right, fantastic. Well, I got you guys on the phone, so to speak, or on the podcast. Perhaps you can say a bit about the future of Flink. What initiatives are currently underway, that are evolving Flink over the long term?
So Flink is a reasonably young project. What we've started to see is Flink gain more and more maturity over the time. So examples of this are the source API, or the APIs generally are becoming more stable and having fewer sort of breaking changes between versions. And one of the drivers is to create stable source and sync APIs so that we can decouple parts of the framework and allow them to grow independently, but not constantly break because things are changing under the hood. So that's one theme. And as Flink becomes more mature, we're seeing other frameworks building building connectors for Flink rather than Flink building connectors into them. So some examples are Apache Iceberg, Apache Hoodie. They both have Flink connectors in their code base rather than Flink having to put them in the Flink code base. So this is kind of, as Flink becomes more reputable, it's kind of like it's the de facto standard now. So these connectors are being built, and within this. Sorry, go on.
No, go ahead.
Okay, and within this stream, we're also seeing support for later Java versions, etc. So Java 17. Yep. So in terms of the feature set, there's recently and in upcoming features, there's a lot of push towards higher level abstractions. So at the moment, SQL is a hot topic, and Flink's building out more and more features around SQL and making it easier to run SQL queries. The benefit of SQL here is that the user doesn't have to have a deep knowledge in Java or Scala or Python, and you can get started very quickly with simple SQL queries.
Oh, nice. Okay.
And possibly more fundamental, Flink is the direction Flink is going is we're seeing more contributions towards the scaling, so better auto scaling, so localized auto scaling. So you might want to only scale parts of the job graph rather than the whole job graph, and improvements around the what is called reactive mode, which essentially is tied into auto scaling, but in an attempt to reduce downtime. So if you can imagine a stateful streaming app that processes state with real time, if you're interested in very low latency and real time, then any downtime is really critical, as you're going to be losing, or you're going to have a higher latency in your results. So making Flink or reducing the downtime of Flink when it restarts a job or when you need to migrate to different hosts, for example, is very important and being discussed by the community.
Yeah. I was going to add to that. I think I think that's a very good point, right, Danny? Because I feel like we said Flink's core potential is on a streaming application, right? So in a streaming data processing compared to a batch data processing, right? So in batch data processing, you run something and then you spin it down, right? Whereas in the streaming processing, you spin it up and it's constantly running, right? So I think relating to this lower downtime and scaling, the reason why scaling is a thing is because we know data gets generated at different rates, right? You may generate lower amount of data now, but then you will then suddenly generate a big burst of data, right? So how do you handle this kind of cyclical cycles, right? And scaling is a big part of that. And to be able to scale quickly with low downtime and automatically scale is a big thing. And that's why Flink is investing in that.
So in our next podcast, we're going to be delving into the managed service that AWS is providing for Apache Flink. But for those who want a little preview now, I was wondering maybe you guys could talk about the AWS managed service for Flink and what the advantages are there.
Yeah, sure. So at AWS, we offer the Amazon managed service for Apache Flink. As it says on the tin, it is essentially a managed Flink job. So we spoke a bit around Kubernetes and Java deployments, etc. So we take care of all of that for you. The developer just needs to focus on implementing a Flink job, and then we'll run that job on behalf of our customers. This includes provisioning all the underlying infrastructure, managing the state, like storage of checkpoints, save points, etc., and also monitoring of the availability of the job. So we actually, our SLAs are around the availability of your job, not your cluster. And to hear more, then you'll have to tune into the next episode.
All right. Terrific. Those are all the questions I had. Are there any other aspects you think might be worth mentioning in an introductory podcast about Apache Flink?
No, I think we covered most of it. Flink is streaming. You can it's open source, so you can contribute to it if you want. You can take down the code, look at the code, run it up locally, see if you like it, right? But generally, it's something that's really useful, and you should be using Flink if you have any like real-time data processing needs, right? And if you want to run it in a big cluster, right? You want to run it in a distributed manner.
Yeah, and so we've been hearing a lot that whereas the real-time thing used to be mostly for fintech and I guess the military, it's becoming more essential for all enterprises. So if you're doing data analysis, you should be looking into how to do that in real time, maybe for a competitive advantage. I don't know. So Danny and Hong, thank you so much for taking time to get us up to speed on Apache Flink, and thank you, listeners, for tuning in, and we'll see you at the next episode of the New Stack Podcast.
Great.
Thank you.
Thanks.
Bye.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.